So A times B equals B times C. First thing you should do again when you're looking for patterns, try to just come up with some numbers or something, some different situations, whatever, to throw in there. Give me a number for A.
7.
7. Give me a number for B. And you said B was 5. When we look at that, what's C? 7. Give me another number for A. 10. Give me another another number for B. 2. Oops, you just told me B was 2, not 10. What's C? Anybody catching on to anything here?
C will equal to
So A must be equal to C. Is that a pretty good conjecture? Okay. Next question. 14. The relationship between the angles of a triangle with all sides congruent. Let's see how well I can draw here. Does that look like all the sides are congruent? Sure. Pretty close. Anybody notice anything about the angles? It might be, they look like they're equal to each other, right? Let's try another one, see if I can draw another triangle that's. Angles all look the same in that one? That wasn't drawn as well, was it? Looks like what? Those sides aren't even? Pretty close.
That looks like. But the one on the far left is it's shorter than the other.
Which one's shorter?
The one that's going down.
The left one.
This one?
Yeah.
Maybe something like that. What looks to be true with this one? The angles look the same? So what might be the conjecture that we can say here? If all the sides are the same, what do we know about the angles? So all angles are congruent. Is that the only conjecture that you could have come up with? If you weren't sure, especially from my drawings, if you weren't sure that all the angles were the same, what else could we say about all these angles? They're all acute. You could say all angles are going to be acute. Would that be an all right conjecture? Yeah. And that we could be sure of, right? If I would have taken my time and grabbed the ruler, and maybe we could have been sure that all the angles were the same. Next question. Sixteen. Relationship between the volume of a prism and a pyramid with the same base and equal heights. We had these formulas, and we could use the formulas, and I will at the end of this, but for now, if I just draw, we got a prism. If I can draw something that looks sort of the same. What kind of prism do we have there? Rectangular prism. Kai, put it on my desk, man. Rectangular prism. doesn't really matter with a prism which one it is, but we'll just consider that one there, the base. And if I draw this, I don't know if I can draw this very well or not. We'll see. Okay. This is supposed to be the same size as that base. Might not be. We'll go with it though. And then there's both supposed to be the same height. So this is our base on this. That one down there, that's our base. And our heights here, this height and the height of the pyramid here are supposed to be the same. What's true about the volume? How much will the prism, the rectangular prism, hold in relationship to the pyramid, do you think? It'll hold more, right? And I would probably accept that as a conjecture. A rectangular, or we don't even need a rectangular, a prism will have a larger volume. That's an alright conjecture. So if you're trying to fit stuff inside something, would you want to build a prism or a pyramid?
No.
A prism. If you want to fit more inside of it. Now the formulas that we had, the formula for a prism for volume was this. Volume, ignore that, equals B times big B times H. For a pyramid, the formula was volume equals 1/3 times big B times H. Can we be a little more precise with the volumes now, if we look at those formulas? What can you tell me about the rectangular prism and how it's going to relate to the pyramid? How many times bigger is it as far as the volume goes? 3 times bigger. So we could have said that a prism will hold 3 times as much as a pyramid. Next question. Say again. 24. 24. Given 2a squared equals 72, conjecture a equals 6, write a counterexample. 2a squared equals 72. So if we were to solve this, might have to have your calculators out to help me here. We divide both sides by 2, you end up with a squared equals 36. What's the next thing to solve that? Take the square root, a equals 6. So that looks like that's correct, doesn't it? Except when you did this in algebra last year, anytime you had a squared term in a problem, how many solutions should you have came up with? If it's squared, you should come up with 2 solutions. Well, we only came up with 1. What's the other one? A equals -6. So what's our counterexample going to be to show that this statement here is not always true? A equals -6. That's our counterexample. You're just showing an example that shows that the statement's not always true. So remember, when you're doing stuff like this, and we've done some of this already this year when we were dealing with Pythagorean's theorem, but we just wanted the positive answers because the length of a segment had to be positive. Couldn't be negative. So when you're doing this in algebra, though, your answer here, when you take that square root, should be a equals a positive or a -6, not just one answer. Other questions? Keith, get all my emails? You didn't check them? That's not good. That's true. Well, I don't know about that. I'd probably rather have him lie to me. At least then I don't feel stupid for doing it. Come up here, grab. There's 2 pages for the notes. Please make sure the notes get into your binder right where they belong. And also grab the passes for the second 9 weeks. Start filling in what you need to fill in on this. Kylie, what's that thermostat up there say? What's it say? 70? Really? Man, it feels like it's hotter than that here today, doesn't it?
That would be 75. 70.
Just 70 even? 70? Feels like it's roasting.
I don't know, it feels like it's so much hotter.
Fill in what you need to fill in on this first part. Make sure you follow along, because here in a few minutes we're going to work some problems out of the book and you're going to have to answer questions, each of you. So Kylie's going to have to pay attention. She can't be in Kylie land for the whole time.
Not today.
I might have to flip his hair back out of his eyes so he can help me out. So on the statements, conditionals, and biconditionals. First of all, a statement is any sentence that is either true or false, but not both. And I've left the blank here for an example. Make a statement up for me.
Trees red.
Say it again.
Trees red.
The tree is red. I don't know why I capitalized red, but whatever, all right? Statement is anything that can either be true or false. With truth value, I don't know why, but some math person thought that they were being clever and sounding real intelligent and making it truth value. When you find the truth value of something, what are you doing? Tell them whether it's what? True or false. Don't make it harder than it is. All right? They tried to make it hard so that Keith couldn't understand it and call it the truth value. You just tell them whether something's true or false. A negation is a statement that has the opposite meaning. Be careful. All right? If I say it is raining outside, what's the negation of that?
It's not raining.
It is not raining. Don't say it is sunny or it is snowing, or that's not a negation. All right? That completely changes the whole statement. So it is raining outside. The negation of that is it is not raining. a lot of times, throughout the rest of this chapter, a lot of times, we'll use just letters like P, R, Q, so that you don't have to write out a whole sentence. All right? So this is just some statement. This is just some other statement. This is some other statement. Just so you don't have to write out a whole sentence. It makes it shorter. So this is just a statement P, statement R, statement Q. The symbol for a negation is this little tilde, not with the equal sign below it, because that's a congruent symbol. All right, it's just a little tilde. So this, if I write something like this, with that tilde and then P, that means not P. Or it's red, not P. If I write this, not Q. Whatever the statement for Q is. And they'll give you statements, and you'll have to write stuff out. They'll give you a statement, and they'll say like, P, that statement stands for the tree is red. Then they might say something like R stands for 1 plus 1 equals 2. And you'll have to write out a sentence from what they're telling you. And we'll do some of those. Not real hard, it's just a little bit of writing. Compound statement. Compound statement is two or more statements joined by the words and or. Keith knows what those are because Saturday when he's sitting at home watching this cartoon Saturday morning, he's seen the Schoolhouse Rock thing. How'd it go? Come on. I know you guys know it. You guys aren't acting. Everybody's trying to act cool like they don't know what it is. Look, Cooper knows what it is. He just doesn't want to sing
I
it.
don't.
The little engineer guy.
What's it called?
Schoolhouse Rock is like a commercial. It's one of those commercials that's in between the cartoons. The guy comes out. You're gonna make me sing it, aren't you?
Yeah.
Conjunction, junction, what's your function?
yeah,
Hooking
yeah.
up words and phrases and.
That was terrible. I read it on TV.
Yeah, you guys he said I read it on TV. So that's a compound statement. Now on that Schoolhouse Rock thing, they call them all conjunctions. It's different in math. Math, a conjunction is a compound statement that uses the word and. It has to use the word and. That's a conjunction. All right? And we're going to talk about something on the next slide. If you look on down on your notes, you can probably figure it out. That's going to use the word or. So my conjunction that I put up there, my compound statement was a quadrilateral has 4 sides and a quadrilateral has 4 angles. When you're looking at conjunctions or disjunctions, this is what you do. You look at the first part. Is that true or false? Does a quadrilateral have 4 sides?
Yes.
Yes. So it's true. Then you look at the second part. Does a quadrilateral have 4 angles?
Yes.
So that's true. for a conjunction, for this statement to be true, both parts have to be true. So is our conjunction here true or false?
True.
True. Kylie, back to this world. A conjunction is only true when both parts of the statement are true. A conjunction could be written this way, P and Q. Again, it's got the word and. P stands for some statement, Q stands for some statement. Don't make this harder than it is just because the book was lazy and had to stick stuff like that in there to... The other thing, this right here is the symbol for a conjunction. Make sure it's that upside down V. That's the symbol for a conjunction. Better get rid of that. Conjunction. Can't spell. That's the symbol for a conjunction. So anytime you see that upside down V, it's telling you the word and. So Kylie, if I write that, what word? I knew you were paying attention. Next one, disjunction. Disjunction uses the word or. Uses the word or. So same idea with the disjunction. See the word or here? You look at the two parts. A quadrilateral has 4 sides. Is that true or false?
True.
A quadrilateral has 4 angles. True or false?
True.
Now with a disjunction, only one of the parts have to be true for the entire thing to be true. You guys probably use disjunctions on your parents all the time. What do you need money for? Oh, we're either going to go out to eat or we're going to, and then you tell them something else. And then when they come home, they say, you lied to me. No, I didn't lie to you. We did do this other thing. And they said, no, you told me you were going out to eat. No, I said, or. I didn't, so that means both of them don't have to be true. Only one of them have to be true. And Cooper makes sure that he's far enough away from Cindy that she can't reach him when he's saying all this, because if he's too close, if he's within arm's length. All right, so with a disjunction, only one part has to be true. The actual V-looking symbol, that means or. So upside down V, and, right side up V, or. This is just a chart there that I put in there to help you out. All these different symbols. What's that symbol mean again? Not. What's this symbol mean? So it's what word? And. What's this one mean? Or. Make sure you know those symbols. I don't think there's anything to fill in on this part, is there? I forgot to leave anything out. Very, very important. You might want to put an asterisk beside this. Used to be at this point, I'd tell you that for sure on the final exam, there's going to be a question that says, what's another name for a conditional statement? I'll have to make up a new final exam this year because we got new books and everything. So maybe I'll throw it on there, I don't know. But another name for a conditional statement is just an if and then statement. if and then statement. And all an if and then statement is it says if and then gives you some statement, and you know that part's true. Then it says then, and it gives you a second statement. You got to decide whether it's true or not. The if part is called the hypothesis. You might want to underline that right there. The if part is called the hypothesis. The then part is called the conclusion. If is the hypothesis, then is the conclusion part. The hypothesis does not include the word if. The if stays there all the time. That's not the hypothesis itself. It just shows you where the hypothesis is. So then the same thing. It's not part of the conclusion, it just shows you where it's at. So on your paper there, on these three examples, we're going to do them together. This is the part I want you to fill in on your notes. What's the hypothesis of it is raining, then the grass is wet? Just underline that. It is raining. That's the hypothesis. That's the hypothesis. What's the conclusion? The grass is wet. Next one. If P, then Q. What's the hypothesis here? P. It's just that. Hypothesis. What's the conclusion here? Q. You can abbreviate them if you want to make it a little easier on you. If two angles are vertical, then they are congruent. What's the hypothesis? Two angles are vertical. Remember, not the if, just the everything after that. What's the conclusion? They are congruent. Hypothesis, conclusion. On these, you're going to have to, a lot of times, you're going to have to tell what the truth value of each statement is, so whether they're true or false. This first one, if it is raining, then the grass is wet. True or false? True. Could you maybe come up with a counterexample? Yeah, you might be able to. Maybe it's under shelter or something. Who knows? How about this one? If P, then Q. Is that true or false? Do we know what P and Q are? So we'd have to know what P and Q are to be able to tell that. Next one, if two angles are vertical, then they are congruent. Is that true or false? If two angles are vertical, does everybody remember what vertical angles are? Which angles in that picture are vertical angles? 1 and 3. What do we know about angle 1 and 3? They're congruent. So is this a true or false statement? It's true. What if we turned it around? What if I said, if two angles are congruent, then they are vertical? Could be true. I don't know, just because if I give you these two angles, they're congruent, right? Because I marked them congruent. Does that mean they have to be vertical? Not necessarily. So that's what you're going to have to do, and that's what this next part does. We're going to fill in some stuff here in a second. Find this on your paper. This is, again, you might want to put an asterisk beside this. Pretty important. Not very difficult to do. It's just usually a little bit of writing. All these are 3 ways to change a sentence or change a compound statement. We're just taking stuff and moving it around and changing stuff up a little bit. So the original, write this in, this is the original. That's your original statement. What's the hypothesis in that original statement? P. What's the conclusion? Q. Nothing hard so far. The converse of a statement. What's the converse of a statement do to that statement? Looking at it, what did that converse do to it? This is the converse. What did it do to the original statement? It switched them, didn't it? That's what I want you to write right here. Switches, hypothesis, and conclusion. Sorry about that. And it switches the hypothesis and the conclusion. So it just switches the two. Not the if or the then, but the hypothesis itself and the conclusion. Going back to the original statement again, the inverse of a statement. The inverse makes it look like this. What did that do to the original statement? What did it put in? What's those little tildes mean again? Put not in both parts, right? Didn't switch the order. It just put in the opposite of whatever the hypothesis was, the opposite of whatever the conclusion was. So the way we say that in math, it negates the hypothesis and conclusion. It negates the hypothesis and the conclusion. Anybody tell what the contrapositive does? Looking back at the original statement again.
Switches it and puts it on.
Okay, so that's what we're going to write. Switches and negates. It's all right if I leave off the hypothesis and conclusion part. Can you guys handle that? It switches and it negates the two parts. Mistake that a lot of you are going to make. Got to remember, each time you're doing one of these new statements, each time you're making the converse or the inverse or the contrapositive of the statement, you've got to always go back to the original statement. Don't look back at the converse or the inverse if you're doing the contrapositive. Look back at the original to see how you change it. Let's give me some definition that we've used in here this year. Tell me some term that you know. Nobody knows any terms. That means we should probably, I got a definitions test laying back there that we're getting ready to take, that we need to probably take today, don't we? Yeah, we do. So give me something. What's something that you know? So, if, let's use something different. I'm trying to make it as easy as possible. Give me some easy definition. What's something that we've had, a term that we've had that you know the definition of? Different angles or something. None? What was synthetic? Synthetic dealt with graphs. So if synthetic geo then, and I'm just going to write this rule. Don't write like this in your English class, all right? When we write in here, it'll be a lot of sort of caveman talk because I don't like writing. So it'll say like, if synthetic geo, then graph. What's the hypothesis in this case? Synthetic geo. What's the conclusion? Graphs. If I wanted to write the converse of that, what's the converse do to the statement? Switches it. So what's it going to say? That's all it is. If graphs, the if still stays in the front, the then still stays back here, then synthetic geo. Inverse. What's the inverse do? Okay, negates both parts. So what's it going to say? If not, remember, go back to the original. If not synthetic geo, then what? Not graphs. Make it make grammatical sense. It doesn't have to be perfect or anything, but contrapositive. I hate writing out the word contrapositive. It's all right if I abbreviate it like that every time. Is that going to confuse you, Kyler? Contrapositive does what to both of them? Switches and negates. So what's it going to say? If what? If not graphs, then not synthetic geo. Now the other thing that they're going to want you to do on these statements is they're going to want you to tell whether they're true or false each time. We're not going to go through and try to decide if those are true or false. We'll do that on another example here in a second. But that's all the converse, inverse, and contrapositive are. You're just taking that original statement and sort of mixing it around, doing different things to it. Is this on your notes somewhere? We're going to do this example together. First thing, you're going to write a conditional statement. So we're going to take this statement that they gave us and we're going to turn it into an if and then statement. So our statement that we were given says a polygon with 4 sides is a quadrilateral. How can we write that as an if and then statement? If what?
If there's
That's all right.
If polygon, then 4 sides.
If
Or
a polygon, then
with 4 sides.
if a polygon with 4 sides, then a quadrilateral.
So if a poly, and that's what you have to do sometimes, you have to make sure it makes grammatical sense, right? If a polygon, what? Has 4 sides, then is quadrilateral.
I can't see.
So this is our original statement. This is the original statement. Is it true or false? That's true. So we want to say, hey, that's true. What's the hypothesis of this original statement?
Polygon is 4 sides.
That's the hypothesis. What's the conclusion? Ignore that. Now we want to write the converse, the inverse, and the contrapositive. We'll start off with the converse. Looking back at your notes there, what did the converse do to the original statement? Switching. Now, I would be writing this down in your notes. I guarantee I love these things because they're pretty easy for me to grade, and they shouldn't be hard for you if you know how to do them. So it's going to say, the converse is going to say if what?
If quadrilateral, then polygon has 4 sides.
Does that make any sense? Probably on most of these, what you're going to have to do, that's the subject of all this whole sentence. Where's that subject have to fall at in a sentence when you're writing in English class? at the beginning. So you're probably gonna have to leave that in the beginning. So what's our statement gonna say? If a polygon is what? Is a quadrilateral. So if polygon is quadrilateral, ignore that. Polygon is quadrilateral, then what do you know about it?
And there's 4 sides.
And has 4 sides. Is that true or false? True? The inverse. What's the inverse do to a statement? Negates it, right? Leaves it in the same order it started it off being in, but it negates it. So what's it going to say?
If not, has 4 sides.
If not, polygon has 4 sides. Does that make any sense? Now I don't mind, again, I don't mind talking like a caveman somewhat, but let's not be too ridiculous. So how are we going to make that first part make sense?
Polygon does not have 4 sides.
Okay, so if a polygon does not have 4 sides, then what do we know about it?
Then it's not a quadrilateral.
Then not a quadrilateral. Spell that right. Is that true or false? That's true also. So we got the converse, we got the inverse. What's the last one? Contrapositive. What's the contrapositive going to say? You guys are my smartest class, right, Keith? So, I'm going to tell you this, but I don't want to confuse you, all right? So if you think that I'm going to confuse you right now, put your fingers in the air, go to Kylie Land and visit her for a minute. If we look right here at the inverse, what the contrapositive does is it takes that inverse, the way you have it written right there, and it switches those 2 parts. All right? Does that make sense? It just takes this inverse, and you just negated the 2 parts, right? But now what it does, it takes this part, sticks it over here, takes this part, brings it back to there. So, Cooper, you look like you got confused look on your face, and forget that. We go back to the original, it's going to switch the 2 parts and negate it. So what's it going to say?
It's not a quadrilateral.
So, and again, we need to go back and make sure it makes sense, right? So, if a polygon
It's not a quadrilateral.
is not, I'm tired of writing quadrilateral, is it all right if I abbreviate that? If a polygon is not a quadrilateral, then what's true?
Then
And does not have 4 sides. Is that true or false? Usually the contrapositive is the hardest one to decide whether it's true or false. And I'll tell you this, if the original statement was true, 99.9% of the time, the contrapositive is also true. Fill in what you need to fill in on this. It is making sense. it. No, I'm talking about, I know you can read my stuff. Can you read yours?
Yeah.
All right. 'Cause I bet if I handed it over here to Sean, he could.
Probably not.
Moved that mask like 15 times while you've been in here. So if you see something that looks like this is just some symbolism that we're going to use throughout the rest of the year. If you see something like it says this, this is just red. Joe implies Fred. All right? So what that would tell me is every time I see Joe, what else am I going to see? Fred. All right? Now, does that mean every time I see Fred that I'm going to see Joe?
Yes.
No.
It doesn't. Joe implies Fred. Does it work backwards all the time? Not necessarily, right? Now, if you do this, if I do this, Kendall, and put that double arrow in there, then when I say Joe implies Fred, it also means Fred implies Joe. So now every time I see Fred, am I going to see Joe also? Yeah. If it's got that double arrow, then it means it works both ways. Just because something works one way doesn't necessarily mean that it works the other way. Let's go back to our grass thing. Raining outside implies to us that the grass is wet, right? So that makes sense. If it's raining, normally the grass is going to end up being wet. Does it work both ways? If the grass is wet, does that mean it has to be raining outside? No, a lot of times you get up in the morning and what's on the grass? Dew. And the grass is wet. So it doesn't work both ways. Equivalent statements or logically equivalent. Again, this is another one of those math things. We'll probably hardly ever talk about this because I think it's stupid. Some math person wanted that seemed intelligent and they made up this stuff. All that means is that they have the same truth value, or they're both true or they're both false. Nothing hard about it. Biconditional. This is biconditional. If a statement and its converse are both true, so if it works both ways, then it's said to be biconditional. And we can write it this way. No, Kaylee, I didn't misspell if there. That's actually what we use. All right? So this says IFF. It means if and only if. So if I were to write this, this would say Joe if and only if Fred. And that tells us that everywhere we see Joe, who else do we see? Fred. And everywhere we see Fred, we see Joe. They're always together, whatever. All right, that's what the if and only if means. And it's written like this. What's this symbol again? This one. And. All right, what's this symbol again? Or. What's that symbol?
Not.
Not. Good. Get your books out, page 167. 167. We got about 20 minutes or so, 30 minutes, 25 minutes. Open up your books to page 167. Or 161, not 167. Jeez, I can't read. 161. Open up your books to 161. We're gonna go around the room and you're gonna answer questions, so everybody's gotta be where we're at.
Are you sure? Cause this is what.
161, yeah, there's an example at the bottom. So everybody see example 1 at the bottom. That's what we're doing. It's not on your notes or anything, you write your answers right there in the book, we're just gonna go through and do this. Example 1. Example 1, part A says what, P and R? Is that what it says? Kendall, help me out, what's P? Look down, or look up there, they tell you what P stands for.
Figure
The figure, does everybody see where she got that from?
Yeah.
Is a trapezoid. This is what you're gonna have to,
There's also two.
I know, but just for A, all we need is P and R. Figure is a trapezoid. This time, they tell us to use the word and, right? Kylie. Kylie J, sorry. What's R?
The figure has 4 right angles.
Use your abbreviations and stuff to make this shorter on your writing. We're trying to decide whether this is true or false. First of all, they give you a picture out there to the side, don't they?
Yeah.
Is that, we check this one. Is that figure a trapezoid? True or false? Anybody? False. We use the word and. What's that tell you when you use the word and? What has to be true for the statement to be true? One part or both parts? Both parts. Figure has 4 right angles. Does this figure have 4 right angles? So that part's true. So we got this part's false, that part's true. What do we know about the whole statement? It's false. That's what you'd write down. It's false. Part B says this. Help me out, Hannah, read this to me. What's this symbol? Not P. All right, Kai, what's this symbol? Other one. And then Q, right? So that's what we're going to write. Keith, help me out. What was P? The statement that they gave us for P. The figure. Now, we want to negate it this time, Keith, so are we going to write the figure is a trapezoid? If we want to negate it, what are we going to put? The figure is, listen to what they're telling you. The figure is not a trapezoid, right? The figure is not a trapezoid. Then, Kai, what word are we going to write? And. All right, Sean, what was Q? The figure has 4 congruent sides. Now we look at this. Remember, we use the word and. The figure is not a trapezoid. True or false? Anybody? True. It's not a trapezoid, is it? Then we look at this. The figure has 4 congruent sides. True or false?
True.
What's that tell us about the entire statement?
True.
It's all true. I think they give you a blank there that you could write your answer in, don't they? Flipping over to the next page, example 2. Example 2. So page 162. Does everybody see P, Q, and R there this time? So they ask us, let's see, what do they say? They do this. P, that symbol, then that symbol, then R. Help me out, Cooper, what's P say?
The angle ABC and angle CBD are
CB what? D?
CBD.
Are complementary. What's complementary mean again, anybody?
The same.
They add up to 90 degrees. Congruent means the same. Supplementary means they add up to 180. Complementary means they add up to 90. What's the symbol tell us, Caleb? Or. What's this symbol tell us, Kylie B? Not. So we're going to have to put not in this, right? So it says not R. Sorry, Gretchen, I didn't mean to skip over you. I'll get back to you. Not R. Kylie B, what is R? Look right where the up, right above. What's it say R is? On example 2. So AB is congruent to, segment AB is congruent to segment BD. Is that what we wanted to write there? What'd they tell us? It's not true. So we don't want to say that they are congruent, we want to say that they are not congruent. So we might put a little slash through that. So looking at the pictures, Gretchen, looking at the pictures, angle ABC and angle CBD, do they add up to 90?
ABC and CBD,
Yeah.
they do not.
They add up to 180, don't they? So that part's false. Segment AB is not congruent to segment BD. Is that true or false? Look at the picture. Do they have them marked as congruent or not? They do, don't they? So is this part true or false? False. So this part's false, that part's false. What's it tell us about the whole thing? It's all false. Example 3, find example 3 there. So we're on page 163. See it, Keith? Is that a yes? Look at part B. They've already done part A for you. Look at part B. Another performance will be scheduled if the first one is sold out. Let's write that as an if and then statement. How are we going to write it? If what?
Sold out.
If sold out, then another performance, and I'm writing this real crappily, scheduled, right? What's the hypothesis this time?
Sold out.
So in that little blank right there, you can just write sold out. So if it's sold out, that's the hypothesis. What's the conclusion? Another performance schedule. That's all you're doing on those. Picking out the hypothesis and the conclusion. Look down where it says check. Does everybody see where it says check? It says, if the forecast is rain, then I will take an umbrella. What's the hypothesis, Kendall? Close. Leave off the first word. The forecast is rain. What's the conclusion, Kylie J? Or look where it says check, letter A. See check, you see where it says check on page 163? And then letter A. So if the forecast is rain, Kendall said that the forecast is rain, that's the hypothesis. What's the conclusion? I will take umbrella, right? Example 4. Says identify the hypothesis and the conclusion for each statement, then write it in if and then form. 4 quarters. Kai, you ready? 4 quarters can be exchanged. Sorry, I'm writing in cursive, I forgot. Or $1 bill. We want to write it in if and then form. So if what? What are you going to say, Kai? If
You got 4 quarters?
you have 4 quarters,
Then you can exchange them for $1.
then you can exchange for dollar bill. I know, believe me, I hate writing as much as you guys hate writing, but you see, I'm trying, Hannah, right? I'm really, really trying not to do all the caveman talk and everything else, but it's hard for me. Letter B on that one. Oh, I'm sorry, what's the hypothesis?
You have 4 quarters.
You have 4 quarters, that's the hypothesis. What's the conclusion?
You can exchange them for $1.
Letter B. The sum of the measures of 2 supplementary angles is 180. So Hannah, what are we going to do? If what? I don't know. What? How do we want to say it?
You have $1 bill, you can exchange them.
No. We're on letter B. They didn't ask us to write all the different things this time. So it says the sum of the measures of 2 supplementary angles is 180. So if what? We're trying to write that as an if and then statement.
Do we have these other things? Or just like the points?
What do you mean?
You know what I mean? Like if 2 supplementary, oh my god, yes, angles, then it would be 180 degrees.
That would be close.
I would do that.
So if, did you hear what she said? If,
It just says the sum of the measures of which
all right, so if, but we want to make it an if and then statement. If we have what? If 2 angles are Okay, let's turn it the other way. Because that's the way they had it. What'd they say first? If two angles are supplementary, then what do we know about them? Be careful. Are they 180? Then they add to 180. Then add to 180 degrees. So, and I understand it's sort of difficult sometimes, but what you got to do is just sort of make it make sense. What's the hypothesis this time? Hannah, what's the hypothesis?
They are supplementary.
So that's the hypothesis. Keith, what's the conclusion? Looking up here. You don't need to look down there, really. Conclusion is the part with the then, right? So what's the part with the then? Add to 180. That's the conclusion. Flip forward to the next page. Yeah, we're gonna skip right there. The assignment's in the, it's on your paper, right? Get out, we got about 5 minutes. Get out a clean sheet of paper. If you don't want to follow along, go to sleep or something, but don't talk. Number 1 says P and Q. Somebody help me out and tell me what statement they give us for P.
-3 -2 equals -1.
This is what you would write down on your paper. They already told us the word is and this time, right? What's Q?
Vertical angles are congruent.
Vertical angles are congruent. The first part, -3 - 2 equals -5. True or false? True. Second part, vertical angles are congruent. True or false? True. We used and. Both parts were true. What's that tell us about the whole statement? It's all true. So you just write down true for your answer. Number 2. They give us this. What's P again? What's this symbol? And. What's R? 2 plus 8 is greater than 10. That's an ugly greater than symbol, but. First part, true or false? Second part, true or false? We used and, so what's that tell us about the whole statement? Number 3. What's Q?
Vertical angles are congruent.
Ignore that. What's this symbol mean? Or. What's R?
2 plus 8 is greater.
2 plus 8 is greater than 10. But this said what?
Is not.
Not R. So what are we going to do? So 2 plus 8 is not greater than 10. Just put that slash to there. Could be read that way. Vertical angles are congruent. True or false?
True.
2 plus 8 is not greater than 10. True or false? We use the word or. So only one part has to be true for the whole thing to be true. So is this whole thing true or false?
True.
True. Number 4. What's it, R? What word are we using here? Or? So I don't have to write all this down again. What's R say?
2 plus
2 plus 8 is greater than 10. Is that true or false? 2 plus 8 greater than 10? False. What's Q say?
8. Vertical angles are
True or false?
true.
What's that tell us about the whole statement? First part's false, second part's true.
True.
Tells us the whole thing is true because only one part has to be true. Number 5, what's it say? Not P. What's P again?
Negative 3 equals negative 3 minus 2 equals negative 5.
Negative 3 minus negative 2 is, or equals negative 5. But we said we wanted not, so
3 plus 2.
So negative 3 minus 2 does not equal negative 5. True or false? That's false. Don't do that. No! There's nothing I can click. It's going to throw all my stuff away and then I'm gonna start all over. We're on number 5, right?
Yep.
Or 6. So the first part, true or false? False. What word were there? What was that symbol? We were on number 5, weren't we?
Yeah, we
Oh, I had something written down for number 5, so.
First part was false. Not Q. Is that true or false? Not Q. What was Q?
Vertical angles are
Vertical angles are congruent. So vertical angles are not congruent. True or false? False. What's that symbol? And. Both parts are false, and we're using the word and. What's that tell us about the whole thing? Whole thing's false. Number 6.
true.
What's not R going to say? 2 plus 8 is not greater than 10. Is that true or false? True. What's that symbol? Or. Well, what's that tell us? Do we even have to do the second part? If we're using or and the first part's true, what's that tell us about the whole thing? Whole thing's going to be true. Number 7. Identify the hypothesis and the conclusion of each statement. Frederick Douglass said this: if there is no struggle, then is no progress. In other words, if you get something easy, probably didn't really gain anything. What's the hypothesis?
There's no struggle.
That's your hypothesis. What's the conclusion?
There's no progress.
Is no progress. Number 8. Two angles are adjacent. What's the second part say?
Does it have a common side?
What's the hypothesis?
2 angles are adjacent.
Does everybody remember what adjacent means? How much do adjacent angles add up to? Thought I was gonna say good answer for a minute because everybody was quiet, but then somebody answered. What do adjacent angles add up to?
They don't add up to anything, they're constant.
Nothing special, right? They're just neighbors. So that's the hypothesis. What's the conclusion?
They have a common side.
They have a common side. Number 9. I'm not going to write number 9 up there. We can just do it out loud. What's the hypothesis on number 9? 2 words. You lead. What's the conclusion on number 9? 3 words. I will follow. Number 10. What's the hypothesis? 3x minus 4 equals 11. What's the conclusion? X equals 5. Number 11. 2 angles are vertical angles, then they are congruent. What's the hypothesis? 2 angles are vertical. What's the conclusion? They are congruent. Pretty easy stuff. Number 12, real quick, last one. Identify the hypothesis and conclusion for each conditional statement, then write it in if and then form. We're going to write it in if and then form, and then that'll make it easier to identify the hypothesis and conclusion. Get a free water bottle with a 1-year membership. So how am I going to write this as if and then? Let's turn it around, because what would you do first?
If you get a membership, you get a free
So-
water. Then you get a free water.
If you buy membership, then what?
Get free water.
Then get free water bottle. What's the hypothesis? Buy membership. What's the conclusion?
Free water.
Free water bottle.